Hello everyone, my name is Al Amin, and today we are going to be using correlation and linear regression in JASP to answer two questions regarding a data set called Elementary API 2. So this data set um, basically measures the performance index for 400 randomly selected elementary schools in the state of California. So to start, I went into JASP and I imported my data set, as we can see here. And to answer the first question, it is asking me to use correlation and linear regression to describe the relationship between the performance index for the year 2000 and the full, which is the percent of teachers with a full teaching credentials. And it's asking me to report the predicted mean for that performance index if the full value was 25%, 50%, and 27%, or sorry, 75%. So we start our analysis in JASP, and I go to correlation under regression. If I go to regression here and then click on correlation, and then I start importing my variables, which are the performance index for the year 2000 and the percent of teachers with full credentials. And the first thing that we can see that pops up to us is the p-value, which is pretty low, so we can reject the null hypothesis. And the second thing we can see from here is the Pearson's R value, which is the correlation coefficient, which is 0.57, which is pretty significant, telling us that there is a high correlation between those two variables. We can start by looking at some plots, and then we can see that the higher the percentage of teachers with full credentials means that this school is probably going to have a higher API value. Over here, we can also see that the R value is reported. Moving on from correlation to linear regression, to answer our question is we want to report the API value for a full value of 25, 50, and 75%. We are going to use linear regression, and over here we start by importing the API value for the year 2000 as our dependent variable, and then our full is going to be the covariant over here. And then we can see that it shoots up the coefficient R value of 0.574, just like we saw in the correlation tab up above. And over here, it reports the R squared value of 0.33. What I'm interested in is looking at here. We want to look at the coefficients. And the first thing we look at model 0, which does not include full as a variable. It's just telling me that the average mean for our data set of 400 school, the mean API is 647. But once we start incorporating full as a covariant, the intercept is giving me a value of 185.5 for the API, which this is telling me, what this is telling me is if I have a full value of 0, basically a school with no teacher having any teaching credentials, probably the API for that school is going to be very low. So the mean API for a school with 0 teaching credential is going to be 185. But then every increase in teaching credential, every 1% increase in teaching credential is going to give me a 5.5 increase in the mean API for that school. So using this equation over here, we can calculate the API for any given full value. So basically, the API for any given value is going to be the mean intercept for full equals 0 plus 5.5 times the full value. So we're going to have an increase of 5.5 in the mean for every 1% of full value. Sorry, I got to make some movements here to get the motion sensors to work. Sorry about that. So going back, if we look at the API for the 25% full value, we're gonna calculate the intercept as 0, adding 5.5 times 25. This is a value of 323. And then if we look there for the API with a full value of 50%, we calculate the same way and we get a value of 460.5. We do the same for the 75 and we get a value of 598. Something kind of came across my mind when I was looking at the API for the 75%, which is a good significant percentage of teachers having full credentials. And it gave me the value of 598 over here. And if I compare it to the mean of the API for the data set, which is 647, this is telling me that probably those 400 schools already have teachers with higher credentials than the 75%. Because if we only have 75% of the teachers having full credentials, and my mean is 598, then this is telling me that the schools in California already have higher than 75. And if I go to my data set and I look at the full column over here, just glancing over it, I see that the majority of the numbers are in the high 80s, 90s. I have a few hundreds over here, which kind of holds up. So probably this data set, so 400 elementary schools, already have higher teaching credentials than only 75. If I look at some plots here, we look at a marginal effect plots with 95% confidence intervals. It tells the exact same story. The higher percentage of teachers with full credentials, the higher the school API is going to be. Moving on to the second question. It's asking me to transform the continuous variable, the grad underscore scholar, I believe, into 3 categorical variables with equal groups. So if I just go here, glancing over what this means, it's basically the percentage of parents whose highest education level is a graduate school degree. So going to JASP and looking at the grad scholar, I believe, I'm just going to run some descriptive statistics and import the grad underscore scholar as a variable over here up top and cut it for 3 points. And then looking at the descriptive statistics, we can see that the 33rd percentile holds the value of 2 and the 66th percentile holds the value of 7. So what I'm going to do is I'm going to create a new column and I'm going to label it grad category. And this is my way of transforming this continuous data into categorical data. And then I'm going to use this R code to cut these values into 3 categories of low, medium, and high. Basically, anything less than 2 is going to be low. Anything between 2 and 7 is going to be mid. And then anything above 7 is going to be high. Now that I have my data ready, I go back to analyses and then I run another linear regression with my API as a dependent variable. This time I'm using grad category as a factor because it's a categorical data. It's not a continuous data, so I'm going to use it under covariance. And looking here again, we see that it's highly correlated with a R value 0.63, R squared 0.4, and then the P value is very low, meaning we can also reject the null hypothesis. Looking at the coefficient here, it's telling us the same story. The intercept without incorporating this factor here is 647. Once we start incorporating the factor, which gives me model 1 over here, the intercept in this case is 771. This is basically telling me that if we take the high value, schools with kids, with parents who went to grad schools, the mean is going to go up to 771. Makes sense, kind of, that kids with highly educated parents are probably going to be doing better. And then from here, it's telling me that if you have a category of low, this mean of 771 is going to go by 210. And I made these 3 lines over here to answer the question, basically, the question is asking me report the predicted mean of API for the year 2000 for the three categories that we just created. So uh, going back to JASP, we can calculate the API for a school with high degree of kids with parents who went to grad school. It's going to be 771.3. And then if we want to calculate it for a school with, let's say, medium level of parents who attended graduate schools, we take this factor 146, and then we subtract 770. 1.3 from 146, we're going to get 625. That's the mean API for the schools with medium level of parents who attended graduate schools. And then we do the same thing for the low percentage of parents who attended graduate schools, and then it's definitely expected to go lower. So those three values are my predicted mean API for incorporating this factor, which is the percentage of parents who attended graduate schools. And then running some plots, we can see the same picture. I can see my numbers holding up for schools with a lot of kids whose parents went to graduate schools. We can expect the average mean to be, the average API mean to be somewhere between 50 and 800, and I can see my number falls underneath that. And then schools with lower percentage of kids whose parents went to grad schools, we can expect the API to fall low, somewhere between the 600 and 650, and my number also holds up. Same story over here for the percentage of medium parents who went to graduate schools. And this plot basically describes the same values that we were able to gather from here. Thank you so much for listening in. I hope this little presentation answered these questions sufficiently. Thank you.